Hi, this time I would like to share about how can we interface PLC, especially Siemens S7-300 PLC with analog output devices. So analog output devices, in this case, we assume that we have a tank. So assume that we have a tank, this is a tank. Then we have an analog output device, we call it this one as the filling. Assume that this one is a filling valve. Okay, filling valve, which are responsible to fill the liquid from this piping into the tank. And of course, this filling valve is analog. And what does it mean by analog? It means that this valve can be regulated. Okay, which this valve can be regulated in terms of the percentage of opening. Percentage of valve opening. In terms of simple control, we can say that the valve can be controlled in terms of, for example, 100% open, 100% open, for example, or 75% opening, or 50% opening, and etc. etc. In SIMATIC Manager and S7 step, in SIMATIC Manager, especially for SIMATIC Step 7, SIMATIC Step 7. So there is a function which we call as Unscale instruction, or we call it, let's say, unscaling values for analog output. So we use unscaling values. Unscaling values. Okay. How the instruction look like? It is like other instruction. The name of the instruction is FC106 Unscale. Unscale. It has the enable input, enable output, and then this one for input, this one for high limit, this one for low limit, and this one for bipolar. We also have out. Okay, so looking back at the illustration, we have the filling valve, and assume that this filling valve is connected to PLC via address. For example, the address is QW30, whereby W is for the data type, word data type. Data type word. Okay, so word means 2 byte or 16-bit address, 16-bit length of data, 16 bits. Okay, now we're going to look how can we use the FC106. So FC106, normally for ladder diagram, the enabled, you can straight away connect to the left hand side. Then we have input. The input should be double word. Okay, input should be double word. So in terms of explaining to you, we can have, for example, memory double word, for example 100. Okay, memory double word 100. The high limit is 100.0. The low limit is 0.0, and bipolar we going to utilize the memory bit M0.0. It can be any other memory bit, as long as we have to set this particular bit to 0 to make it the construction as the unipolar configuration. And this one is the enable output, and the out is basically assigned for the control valve, the regulated control valve, which is this one. So this one should be output word address 30. So this one should be QW30. Simple as that. So what does it do? It's basically values on inside MD100. For example, the values inside MD100, if the value is 100, for example, if MD100 is equal to 100.0, QW30 will be 27,648. If MD100 is equal to 0.0, QW30 will be 0. Okay, because the configuration is unipolar. So when M0, when this terminal is 0, when this terminal status is 0, the configuration is unipolar. Okay, what does unipolar means? Okay, unipolar means like this. This is the out. This is the in. If we set the in between 0.0 to 100.0, the out will be between 0 to 27,648. Okay, so we are looking the values in between. So if, for example, if we have a value of X, and then PLC will send this value. PLC CPU will read this value. And this particular value is correspond to the percentage of opening of the control, whereby 27,648 is correspond to 100% fully open, and 0 means 0% fully closed. Okay. We can tabulate the value. So for example, we have in, for example, then we have the PLC unit, output unit. Okay, for example, of course, when we have the input is 0.0, the PLC unit will be 0.0. If we have, sorry, this one should be 0 only. Oops, this one should be 0. And if we have the in is 100.0, PLC unit will be 27,648. So we can tabulate other value in between. So let's choose, for example, 25, 50, 75. Okay. So I think it's very simple mathematics, just straightforward. For example, we're going to find the PLC unit for 25.0. So what we have to do is basically the unknown minus 0. So we have, for example, this one, like let denote as an x. So we have x over 27,648 minus 0. So 27,648, which is basically this one is minus 0, x is minus 0, so is equal to 25 minus 0 is 25 over 100 minus 0, so which is 100. So we get x is equal to 0.25 times 27,648. So use your calculator. 0.25 times 27,648. So we have the value is, the value we get for that one is 6,912. Okay, we can do the rest for the 50 at 75.0. So I'm finished calculating. So we have for 25.0 the PLC unit, the unit basically 6,912. For 50.0 we have 13,824. For 75.0 we have 20,736. For 100.0 we have 27,648. Okay, this is just to provide us an impression how the value change in input change the value of PLC unit, which is going to change this one. Okay, so PLC unit is basically correspond to, this one is correspond to the QW30 address. So this value will be in QW30. So next I'm going to simulate and demonstrate to you a simple simulation using FC106, and this particular example using SIMATIC Step 7 and Factory I/O. So I'm using my previous project. In my previous project, I have OB1 as well as FC105. I don't have FC106 here, so I have to add 106 by adding from the standard library. So I click File, Open, Libraries, Standard Libraries, and then just drag and drop FC106. Just press yes. Okay, close this one. Okay, and then I open OB1. Okay, this is my OB1. Okay, I'm going to add FC106 here from library, standard library, FC106, Unscale convert. Yes, and then the input, let me check the input. We're going to use MD100. High limit is 100.0. The low limit is 0.0. It should be in unipolar configuration. The return value is basically the word address. So we can use a memory word, for example, memory word 200 perhaps. And the output is QW30. It's basically, this one is the control valve. Okay, the control valve, the filling control valve, regulated control valve. And then we download. Yes, alright. Let me try. I just open my simulation. I think simulation should be okay. So So now it's already 27,648. Okay, it's already connected to the factory I/O. I'm going to close the control valve on the factory I/O first by modifying this one to 0.0. Okay, so let me put the factory I/O side by side. Okay, this is my factory I/O. I'm going to prepare the simulation first. I'm going to discharge all the, I'm going to drain the water from the tank. So look at this one is the filling valve. So this one is analog filling valve. It is connected to our QW30, the PLC. QW30. Okay, just wait for a few more seconds. So we're going to completely drain the liquid from the tank. Okay, we will then try the value that we already calculated earlier. So let's say we send the value of 25%, and if we send a value of 25.0, we are expecting that QW30 will have 6,912. So this one, look, I already sent 25.0, so QW30 is 6,912. Okay, now I'm going to modify the value to 50.0, which corresponds to 50%, and we are expecting that the unit for QW30 will be 13,824. See, 13,824. Okay, so now we are going to try again to change it to 75.0, and we are expecting that the unit will be 20,736. See, pump is open. Okay, and if we change it to modify it to 27,640, sorry, if we change to 100.0, it will become 27,648. Okay, so this is basically the manipulation of analog values. Okay, let's say just to make it 60%. So if you look at this one is 60%, it's become a different value. Okay, which somehow change the flow, change the opening of the control valve. I just want to show you the control valve. So look at this control valve. Let's say I change it to modify it to 0.0, for example. Please observe this stroke. So see, so this one is closed, fully closed. Let's say I'm going to modify it to 65.0. See, so it's not too accurate because it's just a simulation. Maybe we can use 60.0 perhaps. See, it's about 60%, is about 60%. Maybe if we can change to 55.5, for example. It's 50. It's not very good for 55.5. So let's say we put 60.5. 60.5 is already open. So we just the value. I think the good value to demonstrate is 60.0. 60.0 is approximately here. Approximately. So if we put it 100%, 100.0. So it's already fully open. Okay, so I hope this helped you to really understand on the FC106, which is unscaling values, and this is only applicable for S7-300 PLC. Okay, it is not applicable for S7-1200 or S7-1500.
Okay, thank you very much.